Alright, welcome back. This video, firm costs. We will learn how to calculate fixed, variable, and total costs and how to represent a firm's costs graphically. Alright, so a fixed cost, like we talked about in the last video, fixed input and variable input. A fixed cost is a cost that does not depend on the quantity of output produced. It is the cost of the fixed input. So if we own the machinery or we are renting it, renting the office space, again, that is our fixed cost. Variable cost depends on the quantity of output produced, the cost of the variable input. So typically we think of capital as being a fixed input or fixed cost, and we think of labor as being a variable input or a variable cost. So those two things aren't always necessarily 100% true, but it is a pretty good guide rule of thumb. Again, fixed, that cost doesn't change regardless of output. Variable, it does. So our total cost is going to just equal the fixed costs plus the variable costs. So total cost equals fixed plus variable cost. And again, we see this graphically here. We're going to look at these a little bit more as we go. So let's just move on. All right, so we have a total cost curve here. Now, to tell you the truth, we're usually going to talk about average total cost curves and average fixed costs and average curves, but in this case you have a total cost curve. What's useful about this is that it shows us how total cost depends on the quantity of output, and as you can see, as we produce more, our total costs increase. And in fact, towards the end, as we get further to the right, you see that they start to increase quite dramatically, and so the total costs rise as quantity output increases. All right, we have average fixed cost. The next one will be average variable cost. So this is the fixed cost per unit of output. So again, remember our fixed costs, ones that don't change, they have no relationship with the quantity produced. Fixed costs we take as a given. So initially, when we produce a very small quantity, our average fixed cost is going to be very high because that fixed cost number doesn't change. The quantity, we're dividing it by a very small number, so our average fixed cost will be very large. As we produce more, we are spreading out that fixed cost over a larger quantity. So it's going to continue to get smaller and smaller and smaller. It will never hit zero, obviously, but it also will never increase. So average fixed cost continuously decrease because that Q, that quantity, is getting larger and larger. We're spreading out the fixed cost over a greater quantity, causing our average fixed cost to always continuously decrease. Average variable cost, on the other hand, so again, to define it, it's variable cost per unit. So it's AVC equals variable cost divided by the quantity. In this case, this is our swoosh-shaped cost curve. And what's happening here is that initially the first couple of workers increase our marginal product by so much that they cause our average variable costs initially to fall. Then we hit a point where we start to experience diminishing marginal returns or diminishing marginal product, and as a result, our average variable costs start to increase. So they begin by falling and then they increase. So that's what our average variable cost curve looks like. Average total cost is average total cost equals total cost divided by quantity. So all these averages are super easy. Just divide them all by quantity, which should make a lot of sense, hopefully. So this is what our average total cost curve looks like. It's U-shaped, and actually the next slide is going to explain exactly why it is shaped in this way. Average total cost curve is U-shaped because average total cost falls at low levels and rises at higher levels of output. All right, so average total cost equals, so another way to solve this, ATC equals AVC plus AFC. All right, so average fixed costs plus your average variable costs equal average total costs. Okay, and what's happening here, so why is this U-shaped? It initially decreases, then it kind of plateaus sort of for a little bit, and then it starts to increase again. So why is this? Well, initially, when you are producing a very small level of output, the fixed costs, remember, the average fixed costs are really high initially because there is very little quantity of output for them to be spread over. So we're starting with high average fixed costs. And again, initially our average variable costs might be similarly high initially, not necessarily that high, but what happens is when we add those up, we have a certain number. But then two things happen. Initially, our average variable costs fall because we have rapidly increasing productivity and production based on those first few units of labor. So our average variable costs fall, and our average fixed costs continuously fall. So it's going to cause our average total cost, since both AVC and AFC both decrease initially, it's going to cause ATC to fall, since it's simply the sum of the other two. But then eventually, like we said in previous video or previous slide, average variable costs eventually begin to rise as we experience diminishing returns to our labor. So it starts to slope upwards, and at that point it starts to become the stronger force between AVC and AFC. So even though AFC is falling, the AVC is increasing by more, so our average total cost will begin to increase. Alright, finally, putting it all together. Alright, so you do not need to copy all of these numbers, but what this is showing us is just some numerical examples of what we just have discussed. So you see the quantity increasing from 1 to 10. Fixed costs remain unchanged. So our average fixed costs, again, well, you'll see that over towards the right, but fixed costs remain the same. They don't depend on the amount, the quantity produced. Our variable costs start low, and in this case we're having them just rise the whole time. Sometimes you'll see examples where they will initially fall and then rise. In this case they start off relatively low, but they start increasing, and if you notice, from 1 to 12 it just goes from 12 to 48, then from 48 to 108. By the time we're getting down from like 7 to 8 and 8 to 9, 9 to 10, we're starting to increase by pretty large amounts, so the variable costs begin to rise rapidly. Our total cost equal fixed plus variable cost, so you just add those two together, and again we're seeing there that our total costs are going to be rising, and again towards the end they will begin to rise rapidly. Then when we think about our average total cost curve, so the ATC, it starts at 120 because it includes all of our fixed costs spread over only one quantity of output. Variable cost is very low, starts at 120, but then notice that our average total cost actually falls for a little while because we're producing a larger quantity, and our variable costs aren't increasing by much. Then we hit a point at the fifth quantity of output where they begin to increase, and so we see that U shape where initially they fall and then they begin to decrease. Average fixed cost, we can see, simply decreases the entire time as we just divide our 108 by a larger and larger number. Average variable costs, they rise. In this example, they rise the entire time. But like I said, in a lot of examples you could see where they would initially fall and then rise consistently. This has been a LaMoney production.